All right, so the topic, reflection, go ahead and write that down for me. All right, so I'm going to give you permission to annotate. And then, hold on, let's see what we're going to do over here.
Welcome to Masonette Math. This is Tyana Masonette, and what we're going to do in this tutorial is practice reflecting across the x and the y axis on the coordinate plane. When reflecting anything across the x or y axis, there is a simple rule that we can follow. Whenever reflecting across the x-axis, the x values of the original coordinates stay the same, and the y values become opposite. And when reflecting across the y-axis, the original y values of your coordinates stay the same and your x values become opposite. Alright, let's go ahead and demonstrate the rules of reflection with two examples. One reflection across the x-axis and one across the y-axis. First, we're going to reflect the triangle ABC across the x-axis. I'd like to start by recording where our original points are located. Point A is located at -8, +2. Point B is located at -3, +2. And point C is located at -3, +8. Because we are reflecting our triangle across the x-axis, we know that our x values are going to stay the same, and our y values will become opposite. So we're going to write every x value.
All right, what do we get from that bit of information here? When reflecting across the x-axis, so write that down for me. Reflecting across the x-axis. So we're going to have reflection across x, reflection across y, reflection across line y equal x. So we're going to have different reflections that we're looking at. All right. Before we continue, I'm going to send you a link. I'm sending the link. Click on that link. It's going to bring you to a document on reflection. Go to that document. Go to that document. And I want, before we continue, I want you to read through, make notes on reflection. So I'm giving you 10 minutes to do that. You're going to watch the video after, and then I am going to direct some questions. Let me know if you have the link.
Miss, what you want us to do again? So you want us to watch a video on reflection?
Hold on. So we continue. So we're starting with the link first. Do you have the link?
Link for what, Miss?
Look in the chat and tell me if you see that link, honey.
Yes, Miss.
All right, good. All right. So you're going to click on that link.
Yeah.
And it's going to bring you to a website. You're going to read everything that is there and make notes in 10 minutes on reflection. 15 minutes, 10 minutes on reflection. Come back after 10 minutes. We're going to go through the video. Video is 5 minutes. And then we're going to have a discussion in 5 minutes and then work questions after.
Yes, Miss. Yes.
Everyone seen the link? So should bring you to this page. And you're going to read through.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
All right, we should be finished by now. Gave you extra time. So we're gonna continue now with the video. And then after we do the video, I want you to read through, make notes on reflection. So I'm giving you 10 minutes. Hold on. Where is that now? All right, so we're gonna go with the video. Am I on the right thing? Okay. Okay, good. So we're gonna go with this video. It's going to show you a bit about reflection.
Oh, is the camera on? Hi friends. I'm sure all of you have used a mirror. We use a mirror since it's a reflector of light. But do the other objects also reflect light? Do you know what are the laws of reflection? What is a regular and scattered reflection? All this is coming up in this video. And then we'll finish off with our top 3 questions on this topic. You must be familiar with what is reflection of light.
All right, we don't need anything more from that, more than for you to see the reflection happening. All right, so that's the most I wanted to see, the reflection happening there. All right, so we're gonna come back to this video and taking it back from here. All right, so pay attention to the information being given. Just share a lot of information that is useful.
The X or Y axis, there is a simple rule that we can follow. Whenever reflecting across the x-axis, the x values of the original coordinates stay the same, and the y values become opposite. And when reflecting across the x-axis,
Hold on, I'm going to send this link. Send this link, but the notes you should be writing as you go along. If you miss something, you fill it in after. So I'm sending this
anything
link
across
as well.
the x or y axis, there is a simple rule that we can follow. Whenever reflecting across the x-axis, the x values of the original coordinates stay the same, and the y values become opposite. And when reflecting across the y-axis, the original y values of your coordinates stay the same, and your x values become opposite. All right, let's go ahead and demonstrate the rules of reflection with 2 examples. One reflection across the x-axis and one across the y-axis. First, we're going to reflect the triangle ABC across the x-axis. I'd like to start by recording where our original points are located. Point A is located at -8, +2. Point B is located at -3, +2.
Go again, please.
If it did come out.
The video was black too. It was black.
Oh, how is it
And point
now?
C is
I'm seeing it now.
Oh, okay. My apology. I don't know what I did. Sorry. All right. Thank you. So let me just put it back a bit.
coordinates stay the same and your x values become opposite. All right, let's go ahead and demonstrate the rules of reflection with 2 examples. One reflection across the x-axis and one across the y-axis. First, we're going to reflect the triangle ABC across the x-axis. I'd like to start by recording where our original points are located. Point A is located at -8, +2. Point B
Is it okay now?
Yes, miss. Look like when you reach the point, I get black, but it's a show now.
Hold on. Maybe it's something that I'm doing. Are you still seeing it?
It's black now.
It's not the video, it's me. All right, my apology.
is located at -3, +2, and point C is located at -3, +8. Because we are reflecting our triangle across the x-axis, we know that our x values are going to stay the same, and our y values will become opposite. So we're going to write every x value the same and every y value opposite of its original. Now that we have our new coordinates, let's go ahead and plot them. Point A is located at -8, -2. Point B is located at -3, -2. And point C is located at -3, -8. Now that we have plotted our points, we can now see where our object will be reflected to. Notice how our x values stayed exactly the same and our y values are opposite values. All right, let's go ahead and reflect triangle exactly the same.
All right, so with this reflection, right? Tell me one key thing that she said about the reflection. When you reflect in the x-axis, what stayed the same and what changed?
The X remain the same and the Y turns opposite.
All right.
The
And
Y.
with that bit of information,
Miss,
can you,
one a
yes, go.
positive and one a negative. When it reflect, it become negative.
Right. So it became the opposite. Good. So next thing that I want to ask you, from the reflection in the x-axis, can you tell me what the reflection in the y-axis is going to be?
Miss?
From the reflection in the x-axis, can you tell me what the reflection in the y-axis is going to be?
Negative.
What is going to change and what is going to remain the same?
Miss, the X is going to remain the same and the Y is going to change.
So let's go again now. The reflection in the x-axis, the x remains the same and the y change. So if we're going to reflect in the y-axis now, what do you think gonna happen? Is the same rule going to apply or some differences going to come about?
I think the same is going to
Hmm?
let's repeat the last part over again, Miss.
Tell me what happens when you reflect in the x-axis. What happens?
Miss, in the x-axis, it really doesn't really change that much, except
What changed? Something changed, something remained. What changed?
Miss just the Y part just opposite, Miss, and the X part just remain the same. Miss. It just,
All right. So the x remain and the y change when you reflect in the x-axis. So if when I reflect in the x-axis, okay, nothing happened to x. Oh, so x I star I show when we reflect in the x-axis. And y now have to change. So let me check now. Let me just think about it. What if I reflect in the y-axis now? What is the likelihood that would happen? I know that something is going to change and something is going to remain the same. What you think is going to change and what you think is going to remain the same?
Miss, the numbers.
Which numbers? So I want you to tell me in terms of x value, y value.
Like the x I go value, I mean, positive, like say positive 8 over 2. That's what? No.
All
It
right, good. So in truth and fact, the x is going to do what now?
it is going to turn to negative 8 and 2.
Not negative, you just tell me positive 8. What negative 8? All right, so I wanted to use two words. Change and stay the same. I want you to start from that basis. Let's go back to what happened with the x values. Let's pick up back with the video from here. From about here.
The same, and the y values become opposite. Follow. Whenever reflecting across the x-axis, the x values of the original coordinates stay the same, and the y values become opposite. And when reflecting across the y-axis, the original y values of your coordinates stay the same, and your x values become opposite. All right, let's go ahead and demonstrate the rules of reflection with two examples. One reflection across the x-axis and one across the y-axis. First, we're going to reflect the triangle ABC across the x-axis. I I'd like to start by recording where our original points are located. Point A is located at -8, +2. Point B is located at -3, +2. And point C is located at -3, +8. Because we are reflecting our triangle across the x-axis, we know that our x values are going to stay the same, and our y values will become opposite. So we're going to write every x value the same and every y value opposite of its original. Now that we have our new coordinates, let's go ahead and plot them. Point A is located at -8, -2. Point B is located at -3, -2. And point C is located at -3, -8. Now that we have plotted our points, we can now see where our object will be reflected to. Notice how our x values stayed exactly the same and our y values are opposite values. Alright, let's go ahead and reflect triangle ABC across the y-axis. A reflection across the y-axis requires making all y values the same and the x values opposite. So we're going to keep our y values the same and turn all of the x values, which are negative values, into positive values. Now that we have our new points, let's go ahead and plot our points. Point A is going to be reflected to +8, +2. Point B is going to be reflected to +3, +2. And point C will be reflected to +3, +8. Alright, now we have the location of our new points, we can reflect our triangle across the y-axis. We can see that the y values of the reflected objects are exactly the same, but the x values are opposite. Alright, thank you for checking out this video. Please don't forget to subscribe and enable notifications, or follow me at any of my social media links shown on the screen. If you need further assistance with other types of transformations, such as
Okay. So we have that bit of information. So can I ask the question again now? I'm going to start with the x-axis. What stayed the same and what remained when you're reflecting the x-axis? Somebody got to get this right, you know, as we sometimes going to be playing this video more than once.
The the x stay the same and the y change to negative.
Right. To the negative of it. Not to negative, but to the negative of it. So if it was +8, it changed to -8. If it was -8, it changed to +8. So it changed to the negative of it, or the opposite of it, right? All right, good. All right, so thank you, Kaylee, on that one. Let's see now. What happens when you're reflecting the y-axis?
The negative number become positive.
$67. You can make as
Go ahead, honey.
Makes the negative number turn positive. At the x number, when it becomes y, it turns positive, negative to positive.
Kaylee,
Miss,
were you hearing me just now?
not really.
Okay. Were you hearing me at all?
Yes.
What were you hearing?
Yeah, ask about the y.
The y-axis. Okay, okay, good. All right, so you were saying, go ahead again, honey.
I was saying the negative number of the x-axis, when it becomes y, it becomes positive.
Okay, so the negative. I don't think I get that clearly.
Miss, repeat the question, yes.
Okay, when we're reflecting the x-axis, the x remains the same and the y change. So what happens when we reflect in the y-axis?
Miss, what happened is it changed from negative to positive.
Which one changed?
The negative number. that
Which
was on
value? Is it the X value that changed or the Y value?
the Y value.
Okay. Positive if it was negative, and from positive to negative if it was positive. But in other words, instead of saying having to say both two statements, you can say it the X value um it changed to the opposite, or you can say it's negated, meaning that we multiply by negative. So let's just go over that again, that bit of information. I think that should have been here. Let me go back. That should have been here. Let me see if it was here. Okay. Let's look at this one. So reflection in the x-axis. All right, so reflection in the x-axis. So when we reflect in the x-axis, the x remains the same and the y becomes the negative of it. So if it was -6, it becomes +6. If it was +3, it becomes -3. Go ahead and write this bit down for me. Let me highlight the part that I want you to write down. Right here. Make sure you have this in your book. Everything right here.
Yes, all of that miss in front of my face, miss.
Go again.
All of that in front of my face, miss.
Huh?
All of that, miss.
The part that I highlighted, honey.
Oh,
That part. You see that part?
yes, miss.
All right, let me see if I get a better line to highlight it. See if I use a circle. Let's see if I increase its size. So that part. Good morning, Abby.
Yes, she has left the chat, the meeting.
All right, have that by now. You have that by now, Peter? So this is the y-axis now.
I get it.
This one is the y-axis. So the first one was the x. This is the y-axis. Have that now?
Yes, miss.
All right. All right, so come here now. We're gonna share. We're gonna reflect this in the reflect this in the x-axis. Everyone, you should have annotate permission to annotate. So you're gonna do the reflection in the x-axis for me, Marlan.
Okay. Alright, we can try this something. So, miss.
Oh, you're so quiet. You're cold.
Yes, miss.
You
Kind.
want to sleep?
No, miss. I can't feel cold, miss.
All right. Warm up, man. Go drink some coffee or some tea or Milo or hot chocolate or
Can I get
something.
coffee? Can I get cold, miss?
Hmm?
Coffee? Can I get cold?
Go drink some hot chocolate or something. Warm up, man, so you can talk to me. Kaylee, Marlon.
Yes, miss.
Okay.
Ah, here Marlon coming out. Yes, miss. All right. Kaylee, you want to try using the pen instead of the highlighter? That might give you. I want you to plot
Miss,
the points first before
miss, how you do it? Miss, where am I supposed to do that?
to do the. I want you to just do the asterisk for the points. So you're reflecting in the x-axis. And one other thing that I want you to know too is that when you're reflecting in the x-axis, the same distance that each of these points are from the x-axis is the same distance that they should be from the x-axis when you reflect them. So this is the x-axis. Let me just draw that bit a line. So this is the x-axis right here. And we must know this. We should know this. X-axis. And then I'm going to put the y-axis in red. All right. So here goes the y-axis. All right. So that's the x-axis and there goes the y-axis. So
So,
when
miss,
yes, honey, go
miss,
ahead.
when you're reflecting on the x-axis, miss, it only goes down, right? Like down, or
No. What if the diagram was looking like this? Let's do a ship around things with this. Hold on. I don't want you to think that it goes down. What if the diagram, did I just move it to the same position? Okay. What if the diagram was looking like this? What if it was looking like this? Hold on, Marlon. See if we can move these lines. Yeah. What if it was looking like this? And you're asked to reflect it in the x-axis. Where would it go? Would it go down?
No, miss. I just go above.
All right. So what I want you to see is to see that the reflection, like it's you looking in the mirror, and this is the mirror. So you're gonna drop over here. You're gonna drop on the other side of the x-axis, if that makes sense. So if I reflect over the x-axis, right? If I reflect over the x-axis, then of course I have to drop somewhere over here. If I reflect this it's gonna look, I'm gonna see it somewhere over here. If it was over here and I reflect it over here, I'm gonna see it somewhere over here. In a, if it's
Miss, what if me did reflect you over y-axis?
tell me where would you see it? Reflecting this over the y-axis. Use your
To
pen
the right,
and draw and show me. Draw and show me
right
where you would
here.
see it. Okay, beautiful. All right. So we're gonna turn it. We're gonna turn it back to the original. All right. So when we reflect, it's going to end up on the other side of the line. Change from Gaza to Gully. Does that make sense?
Yes, ma'am.
All right. So let's scroll up a bit. Okay, so we are reflecting this triangle, and as one thing that Kaylee started with, the important one of the important thing is that she knew exactly where it's supposed to land, and that's very important, right?
Yes, Miss,
You ought to
because
know.
wait,
Go
Miss,
ahead, honey.
before Miss, because if unbalanced, it cannot be reflecting.
Okay.
Because one I go say certain amount of numbers are negative towards the other one, which is not the same.
Okay. I think I get what you're saying. Okay. All right. So one other thing that I want to add that you did not get in the video, I don't recall seeing that in the video, is that each point is got to be the same distance from the x-axis if you're reflecting in the x-axis. If you're reflecting in the y-axis, it must be the same distance. So we're going to label this. We didn't have any labels, so let's just put in some label. So we're going to label this, and we're going to label this as being A, B, and C. So how far is B from the x-axis? How many blocks?
2.
2. 1, 2. So we know that the reflection of this point B here is going to be 2 blocks from the x-axis. So 1, 2. So we know for a fact that this point here is going to become what? B what? How do we label it? B what?
Prime. B prime.
B prime. Beautiful. All right. Go ahead and put in the points now for C and A. And label them for me. So I want you to put in the points first. Erase those lines and use the straight lines to draw them. So look, there should be some straight lines that you can draw. I want to see proper asterisk. Take your time, Marlon. Make your point. Let me see if I can reduce the size of the point, if that's from my end, and make your point smaller.
It's points.
So do your asterisks. I need to see the asterisks for the points. So I need to see them. Ah, beautiful.
Miss, I didn't know the line, miss. It wasn't me.
Miss, I mean, right the line.
Oh, okay. So use a straight edge. Use a straight. There should be some straight edge. Use that to do the line.
Miss, I don't have any straight edge. Miss, and that's reflecting over the x-axis. You know? With the x-axis.
Oh, I'm here talking so long and not, and oh my Lord, I don't even know where to start now. I was here talking all along, you know. All right, now I want you to reflect it in the y-axis. And Marlon, you asked me a question and I responded, but I was muted. Sorry. So now I want you to reflect it in the y-axis. And sometimes when they ask you to reflect it in the y-axis, they want you to use the image that you just created. However, today I want you to reflect the object. The object, what we call the object, is the original. The image is a photocopy. The object, so write that down somewhere. The object is the original. And they are going to use the word object on the exam. They're not going to say original, they're going to say the object. So I want you to reflect the object in the y-axis. Sometimes they will ask you to reflect the image. So that means you would have reflected A, B, C prime.
I don't know about that.
Right?
Mr. Marlon to rub it out and wait till I finish that.
Man, Marlon can go on, man. Go, Marlon. Reflect in the yeah, that's fine. Everyone understand, Peter? You get the hot chocolate yet?
Miss, it's been looked after.
All right, who's making it? Daddy?
No, miss, me.
Gabriel?
No, miss, me, miss.
You? Okay. So Peter, tell me now, based on your observation, if I was supposed to make reference to one of these images, how would you know which I'm talking if both of them is labeled A prime, B prime, C prime? What could I do now to make it different?
It's just
I can't change the letters.
no, miss, the coordinates, miss.
No, man, I can't. I'm not looking at the coordinates. I'm looking at the labeling. If I wanted to make reference to one of them, and I wanted to make a specific reference, if I wrote down A, if I wrote this down, which of them would I be talking about? Which of the image? Could you tell which of the image I'm talking about by just that?
Bottom one.
How? How the bottom one?
Because it's labeled differently. That's the
No, they're labeled the same way.
Miss?
Mm-hmm.
They are labeled the same way, yes, miss, but then
different
labeling an opposite order.
But no. They are called ABC prime.
Yeah.
So when you look at it, you would say ABC. You would say A prime, B prime, C prime. You would not say C prime, B prime, A prime. So what I need to do, I need to make a little adjustment. I don't know if anybody can think of it. I need to add something to A, to B, to C.
Miss,
To make it.
time, miss.
Miss,
Next.
negative.
Miss, I the negative sign, miss, because miss is actually the opposite of what is being.
No, 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 no negative. I need to add something else. So if I have one stroke to represent the first image, could I possibly use, can anybody finish that statement?
Miss, I can use one number.
All right, well, that's possible. We're going to use 2 strokes. So 2 strokes. So it's 2 strokes, all right, 2 apostrophes. So each time, if you do 3 image, 3 apostrophes. So it's the first one is A prime, B prime, C prime. The second one is A prime prime, B prime prime, C prime prime. Or we would say A complement, B complement, C complement, and we would say A double complement, B double complement, C double complement. If you were supposed to do a third one, it would be 3 strokes. So that's how you know the difference, all right? Am I still muted? Okay, no. Everyone get that bit?
Yes, miss.
All right, good job. I'm trying to, yeah, just giving your opinion, all right? And you were all thinking well. All right, so you were using previous knowledge, previous skills to think, and that's good. And well done, Marlon, on plotting those points perfectly. All right, what you're gonna do for me now is I'm gonna give you another one. Let's clear the board. Take a screenshot of this for me. Oh, let us write in the coordinates. So go ahead and write in the coordinates, Peter. You haven't done anything on this part as yet. Write in the coordinates for both image, the first image and the second image. Just write in the coordinates for me. You could write them beside them, Peter. You could write them beside it. But that's fine. Writing it there is fine, but you could. But writing it there is fine. So which A are you doing? You need to be specific because that A is for the object and you should be doing the image. You don't use any arrow to show the A. You label it properly. Label the A properly. How should he label the A so I know that he's talking about the second image? Or should he label that first A? So it's clear that we know that that is the coordinate for the second image. What is he missing from the A?
The 2 stick.
You hear that, Peter?
Yes, miss, I do.
What are you missing, honey? Can you repeat? I don't think he heard you.
The 2 stick, each has one. The first example of 1 stick and the second one of 2.
Okay.
Which side do we put the strokes? The left of the air to the right. Thank you, honey. Well done. All right, good. Continue, Peter. Doing well so far.
It's a fish.
Thank you, Peter. You did absolutely well. All right, so thank you so much for that. So have that in your book. I need to see this. Just take a screenshot of this. And I need to see the next question that I'm sending looking like this. All right. Screenshot must should be taken by now. So we're going to clear.
Just a sec, miss.
I'm clearing in about a second. Second pass already. I clear now. All right, we're gonna look at this question before we go on. Read the question for me, Kelly. Haley, read the question for me, honey.
Describe fully the single transformation that maps triangle A onto triangle B.
All right, go ahead and describe it for me.
So Miss, if you just write it or if you just describe it.
So okay, let me scroll and so you can write it on. So tell me what is it that you're looking at. So when they talk about describe the transformation, first thing that they're asking, is it a translation, is it a reflection, is it a rotation, right? So you're gonna say this transformation is a what it is, and then if it's a translation, you're going to tell the vector that translates it. If it's a reflection, you're going to tell what reflection it is. If it's reflection in the x-axis, y-axis, or whatever it's reflected in. If it's a rotation, you're going to tell what type of rotation it is. So that's what they mean by describe. All right. So write it in for me, honey. And you're supposed to can type it. So look if you see that option to type.
Miss, my phone cannot type it, Miss.
All right. So you can write it in for me, honey.
Miss, it's difficult for her to this is not that's why I'm gonna start right. Me I try write it some, but it does not write.
Okay, tell me and I write it for you, honey.
The A's and the Y axis the
So
A's
you're gonna
and the
start off. So you're gonna start off. So describe fully the transformation that maps triangle A onto triangle B. So you're gonna start off by saying this transformation is, and what type of transformation is it? Is it a reflection? It is a rotation? It is a translation? Is it an enlargement?
it is a reflection.
All right, it's a reflection. I know you need to tell me which axis. In the
In the x axis. No.
in the x-axis. It's correct. That's it. So you get 1 point for saying what type of saying that it's reflection, and 1 point for saying which axis it's reflected in.
Yes, miss.
All right, so see you guys today at 3:30. I think I'll do 3. See you guys today at 3 because Marlon, I know that you have class to go off to. So see you guys at 3. And we do from 3 to 5. All right. Kaylee, you'll be joining on YouTube because it will be streamed on YouTube.
Oh yeah,
Class.
miss. I remember for ask you, miss, where YouTube name?
Mathematics Resource Center. Type that in. All right. So have yourself a superb day. Remember to be kind, polite, nice to everyone. All right. And go make today a success.
Okay. Thank
Bye bye.
you.
Mm-hmm.